Welcome to week 3. This week we're going to be looking at business intelligence and analytics, describe statistical model and relationships, know the capabilities and limitations of a dashboard. Your homework you're going to be working on, you have your week 3 assignment, which is discussion questions 1 through 4 and exercise 12. Remember, all work is turned in at APA. You also have your discussion question, which is due by your initial response due Wednesday night. For Chapter 3, why are the original and raw data not readily usable by analytics tasks? So why isn't raw data good for us? Again, reply to your classmates. Understanding what business intelligence is and analytics, learning objectives this week. Learn the methods used in real-world data analytics. Describe statistical modeling and relationships to process analytics. Learn about descriptive and inferential statistics. Define business reporting and understand the historic evolution. Understand the importance of data and information visualization. Learn the types of visualization techniques. Appreciate the value of visual analytics and know the capabilities. So that's what our goal is this week, to really understand what's going on and how does it all come into play. So our opening vignette, Sirius. You've all used Sirius Radio, I'm sure. I've heard of it. I've had it for years. To be honest, I don't use it as much. I've gotten Spotify, my car Bluetooth connects. In the past, I have it to listen to music, but now with my car, I don't use my Sirius as much as I do my Spotify. So what does that mean to SiriusXM? That they're losing subscribers. You buy a car, it already comes pre-installed. It's easy to set up. But now with the newer cars today, with Bluetooth, my phone runs through it. I have just as good phone coverage as that. So there's definitely losing some customers. So what are they going to do? What is market penetration? What are they doing about it? New cars are coming ready to go. So this is becoming a problem with not only that, but the demographics. Younger people don't have disposable income as the baby boomers who are close to retirement, who are looking to cut back. So there's definitely some issues for SiriusXM to be moving forward. So some of the things they had to do was look at improving data cleanliness, bring marketing analytics in-house, develop new segments, extending data warehouse. And we talked a little bit about data warehouses last week. It's a subset. It's where we keep the data offline, but all the data is in there. So these are some of the different things that we had to look at. Let's see, what else did they do? The results, they have a new campaign, so they know what's going on. They have a closed loop visibility, allowing us to see what everything is. And real-time modeling and scoring as we can look at who's doing what, when, and where. So as you see, this is, as we look at some of this, our diagram, here's our end user, but where's all our data coming from and how do we get it? So some of the different things are happening. So that's what we want to look at as we move forward. And that's how they looked at understanding the data. And you all use Amazon, I'm sure, and you get all those recommendations. Those recommendations aren't random. They know exactly who you are and what you're doing. Amazon, Netflix are probably the two best companies that understand their customer. And they analyze the data to give you exactly what they need. And this is what more and more companies need to do. So what is data? Data is the main intelligence behind BI. So analytics readiness. We're going to look at, reliability. What does this mean to us? As we start looking at this, what does our source data reliability mean? Well, where did it originate from? And what's the appropriateness thing? If I'm Amazon, what am I looking at? Who's buying it? Who's actually purchasing it? Is it the father in the household, the mother, the daughter, the son? Who's purchasing it? This allows me to understand who's getting, understanding what the data is really going to be about. So is that data going to be reliable? Does it mean it comes from a reliable source, or is it kind of haphazard? Content accuracy. Is it a good match for what we're trying to solve? If I'm trying to figure out sales in a particular store, I can look at that particular store. If I look at another store, it might not help me. Or I'm looking at a specific item. And this is what we want to look at. Is the data accurate? Is it accessible? Which means, can anyone easily get this to get the answer? Or do you have to have someone pull from a database, get specific answers? You might not be knowing what you're asking for, so you might not get the data. But is it accessible? So someone can drill down into the data. New tools like Power BI and Tableau are very good at this. They allow the user to drill down without having any knowledge of programming or anything. They just, hey, what happens if I look at this? It allows us to look at it. More and more tools are being set up to make it more accessible so that the users can understand what's going on. Now, as much as we want the data to be accessible, we have to make sure that it's secure and private. We can't have it out there for anyone to see, so we have to make sure that people who do have access to it only have access for what they need it for, and they're not hunting for something that they shouldn't have access to. It just becomes extremely important in the HIPAA, the health insurance, and FERPA, which is the higher ed education on protecting data and the users. So these are some of the things we've got to keep them out. Even though we want the users to have the data, we have to make sure it's being used in good faith. Data richness, this means that all the required data elements are included in the data set and essential for richness, which means it has what we need in it. That it has everything that I'm looking for, and it's there for us. We have data consistency. Is it repeatable, or is this a one-time deal? We can look back through history. We say, how did this item sell in the past on this date? So we're looking for, is it consistent? Am I getting the same data over and over, or is something missing from it? So some of the different things we need to think about. Currency and timeliness. If I give you a stock prices from 5 years ago, it's totally meaningless to what's going on today. And this could be the same with the sales of what's happening in the company now. Is the data reliable? Even a 10-minute delay on the stock exchange can cost you millions of dollars. So timeliness is really important. If I'm closing out the store at the end of the day, well, I only need it daily to get my final results. So it depends on what we're doing, but having it months later doesn't help me. So these are some of the things we need to look at. Then with the data, is it data granularity? Does it have enough information in it that allows me to do what I need? Does it have the details? So if I'm looking at a sales receipt, does it have the date, time, store, what items were bought, who is the salesperson? So these are some of the things that you want to look at. You want to make sure your data has everything that you're going to need as you move forward. Data validity. This is the match or mismatch between the actual data and expected data. If I'm expecting someone to have a phone number, I want a 10-digit phone number. A 3-digit or 7-digit phone number without the area code is useless. So you want to make sure all your data has that. And is it relevant? So this is the last thing we want to look at. Is the data that I'm collecting relevant to what I want, what I need to analyze? So these are some of the areas that we want to address. Taxonomy of data. How is the data put together? So we have unstructured, structured, categorical, and numeric, right? These are the basic data. Structured data, we went over that last week. It's pretty straightforward. Nominal, ordinal, numeric, interval, ratios. These are some basic things that, that makes the data easy to find. You have a part number. I can look up a part number. I can look up a sales date. These are hard facts. Makes it easy to look at. If I'm looking at data, I want to look at a store. Well, I have a store ID. I have a part ID. I can say I want to have this sales of this item on this date in this store after, so it helps me makes it simple to go through. So it's very important. Again, everything is collected on it. But when we get to the unstructured data, it's not as straightforward. These can be text messages that I'm looking at, multimedia, videos, images, audio. So this becomes a lot harder for me to look through and figure out what's going on. It's still very important data on how I get to it, but it takes a lot more work for me to understand what it is, because sometimes I can't just figure out what it is. If I'm watching an interview, I might have to sit there and code the interview when an interviewer asks certain questions. What are the responses? Maybe I'm looking for text in a Word document. I'm looking for certain words. So I have to kind of look through these and add them up manually or automate it somehow. But it's a lot more work, but it allows me to have a lot more freedom with what I'm doing. So both are really important as we start looking at them. Art of science and data processing. So data in its natural form or raw state is relatively useless. We don't know what it's like, especially in the unstructured data. So we have to start figuring out, well, what can we do with it? We want to do pre-processing. We're not changing the data. All we're doing is modifying it so it makes it easy for us to understand what's going on and to run reports on it. So these are some of the different things we want to look at. So the first is data consolidation. As we look at data consolidation, Access collects all the data, puts it in one certain area, and allows it to be integrated into us to doing something. Data cleansing, handling missing values in the data. Like I said, so if I have a data thing that required a social security number, there's no social security number, well, I'm going to have to get rid of that data because it's useless to me, or I figure out if I can get the missing data. So this becomes this data cleaning, which we need to figure out real quick to make sure if we can do anything with it. Reduce noise in the data, identify the outliers. If I'm looking at basic income in a certain area and all of a sudden there's one person who's making 10 times the amount of what everyone else is making, well, that's an outlier. And we want to look at that and figure out, is it really part of the data, or is this something that we have to take out and figure out, hey, why did this happen? There are outliers in data that sometimes just we don't want to take that into account because it's going to throw off all our numbers. Normalize. Once the data is normalized, now we can start looking at it. We can actually start figuring out, hey, we want to do something with this data. So once we know that, we can start figuring out, hey, let's construct our reports, figure out what we're doing, and it allows us to understand what we want to look at. So as we look at the statistic modeling for business analytics, we have descriptive, which we're going to get into. Then we'll get into predictive and prescriptive later. So right now, what is descriptive tells us what's going on. Hang on a second. Just trying to find where I am in my notes. I apologize. There we go. All right, so let's look at the descriptive. Start with statistics. Statistics is the collection of mathematical techniques to characterize and interpret data. So this is in a simple way. You probably all do this. You calculate your gas mileage. That's descriptive. Baseball scores, runs batted in, any ratio, right? That is what statistics is. We're figuring out what's going on. And that tells us, where we are currently. right? It's not telling us the future. It's just saying this is where we are today. And it's usually variable times using different formulas. We can use the, as we talked about last week, mode, our average, standard deviation, and all that. So this all helps us measure that, right? Remember the central tendency that we talked about, the arithmetic mean, simply add it up, divide by the number, the mode, mean, medium, which leads us to dispersion and range. All this is part of statistics, right? This is how we can tell what's going on. If we look at the Olympics going on, who's going to win? Well, they run the statistics through all the past races. They can figure out, hey, these are the best athletes. We have the range and variance, which are important to tell us the spread. What is the, how far are things apart? This leads us to the standard deviation, which we get into, and this tells us our bell curve, 99.99% fit into 6 sigma, or our standard deviation. It tells us our range. And if we're out of that, we can look for those outliers. Oh, this number doesn't fit based on our averages. So the statistics is very straightforward. Put it into Excel. It calculates what we want to do. We can use, like I said, Power BI or Tableau. And it gets us into our distribution curves. And then there's a whole bunch that goes in with that. But basically, the statistics is straightforward and it helps us to figure out what we're doing. That will also lead us, let's see something, yep, regression. So as we look at our regression, modeling and inference statistics, our regression is the linear regression. Is perhaps the most widely used analytic technique in statistics. It allows us to predict what's going to happen. So if it's going to rain, people are going to buy umbrellas. How much rain, how much umbrellas. Same if it snows. We can predict if there's going to be 6 inches of snow or more. Well, we can predict that your time of travel for every inch of snow is going to take an extra 20 minutes or whatever it is. So we're able to, putting in the data from the past history, we can now take that information, put it into a regression model, and predict what's going to happen. So if I'm selling a product and I'm selling it at a certain price and I put it on sale, so I sell it at $10, I know I'm going to sell 1,000 of them. Well, according to my regression analysis, if I drop the price to $9, I already know I'm going to sell 1,100 of them. If I raise the price, I'll sell 900, but I'll make more money. So regression allows me to predict based on past experiences. Now, we got to remember that it's a prediction, so it might not always be accurate, but based on history, we're able to figure out what's going on. It's more accurate than guessing. So the correlation, we want to make sure that we don't make any simple assumptions. It's close, but you can't predict everything, but it gives us an idea. Let's see. So if you look at the data on figure 314, you can kind of see, we tabulate the data, we put it into the assessment, we put it into our scatter plot, we figure, does it fit? We can make our assessment, and we can develop a one-time or recurrent use. So it kind of gives us a little bit of idea of what's going on. Some assumptions, linearity. This assumption states that the relationship between the response variable and the explanation variable is linear. That this is expected value to respond in a straight line function. Independence. This is assumption that states the errors of the response variable are correlated with each other. Independence of one error is weaker. Normality. This is the assumption states that the error of the response variable is not normally distributed. So it kind of gives us an idea. Logistic regression, statistically sound probability of something happening, is first deployed in the 1940s and complements the linear regression. Again, we're predicting what might happen. So let's get to data visualization and reporting. This is a big part of what business is all about. It's great that I have the numbers and I can look at them and I can understand them. But if you go into a meeting, no one's going to want to look at the numbers. They're going to want to see it in a form of data visualization. And that's one of the hottest topics right now within business analytics, understanding what the data says by making a picture of it. And Power BI, Tableau, this is what their main purpose was, is data visualization. They don't deal with the number crunching as much, but they work on making it easy to understand so anyone can understand it. Because if I have the best numbers in the world and I can't get anyone to understand it, it is totally useless. So we need to understand what data visualization is really about and how do we implement it. And it's about using the different aspects of it that we want to look at. And by having this, we're able to, if we look at the some of the different charts, we can look at, hey, this is what's happening in this department. Is it working correctly? So it allows us to have this information. It's to provide information to see who's following along, or does it make sense? To provide the results of the analysis. We're going to have this information. Let's summarize it. And part of it, and let's get to the last here, to persuade others to act. And it's not to change their mind, but if our stock price is decreasing, well, someone may not see that fully. So by showing the numbers in a way that makes sense compared to competitors or how the other companies are doing, sometimes that makes it better. You might be selling more product, but we're losing market share. Well, that's a big problem if we start looking ahead. So these are some of the things we want to look at. And the last one is getting us data visualization. What's the visual representation? What does it look like? And it's not just always putting charts and graphs on the board, but it's allowing us to do different things to make it different. So here's a whole bunch of different charts that we'll look at. And Excel has a lot of different charts. And we can look at these as we start going through the charts and what they all mean. And you've used all these probably in the past. The line chart, simple regression, right? Simple, this is what the line chart looks like right here. We have our bar charts, which is over here. Again, when you have a couple categories, you're going to want to put that in. Pie chart is probably one of the most overused charts. It's not overly useful. It does provide us some basic information. Your scatter diagrams are going to look something like this. And this allows me to see, is there that regression that we talked about? Here's my histograms over here. And again, does this look like a normal curve? And if the answer is yes, we can move on. If not, we have to look at some of the different things. So these are some of the different charts that are out here. Your Gantt chart is another one. Actually, this is set up to help us understand what's going on, especially in project management. It's going to help us to say, hey, this is how long a project's going to take, and this was invented quite some time ago. We have our tree, our PERT chart. Again, what is the critical path that we're going through? So which chart do we use? The one that provides us the best information that we need. Each one has a different results that I'm trying to get. So even using a bar chart versus a column chart, well, it's going to give me something different. Maybe 100% column is going to show me something. So just because you have these different charts, see which one gives you the best results for what you want to happen. They're not all the same. Some emergence of visual analytics and dashboards. You have a dashboard in your car. It gives you all the vital information of what you're doing when you're driving, how fast you're going. There's usually some gauges, your gas gauge, your speed, some other pertinent information, which is important for you when you're driving. Well, if I own a business, what is my dashboard? What is it going to tell me? And that's what you want, is what the dashboard is. What is the most important thing? Is it stock price? Is it the number of people I'm helping? How long am I helping someone? If I'm working at a fast food restaurant and there's a drive-through, if I'm the manager, I'm gonna have the dashboard. How long is it taking for these people to get through the drive-through? Are they taking too long? So these are some of the things that we want to look at and consider. Is, hey, our dashboard gives us the most important information. Now, this can be done in Tableau, could be done in Power BI, it could be done even in Excel. It could be done different types of applications. You can program it. But dashboards are meant to tell a story about what's happening in real time and to react. So if I'm worried about my stock price as the CEO of a company, I'm going to be monitoring and what affects my stock price. Maybe it's the interest rates. So I'm going to have that on my dashboard. Whatever you feel is important at the time, you're putting on your dashboard. And that's what the purpose is, a brief summary of everything that's there so you could get the story at a glance. And you're going to customize it. There's not one dashboard that fits for everyone. Everyone wants something different, and you can customize it, make it as important as you need. And again, Tableau, Power BI are excellent tools at creating dashboards so you can figure out, hey, what's going to be there for you. Let's see, what else on the dashboards? Let's see. All right. Some highlights. Data has become one of the most valuable tools. Today, it's the companies that understand data that are going to succeed. The ones that don't probably aren't going to stay in business. With the consumer changing the way that we buy, Amazon has a pulse on it. How many brick and mortar stores have you seen go out of business in the last decade? Some of it because of the pandemic, but a lot of it just that the people don't understand that their customers want something different. What are they doing to make it different? And that's something to think about. Let's see, data in the original form isn't overly useful. You got to make sure it's clean, accurate, that we protect it. Security is a huge part of it. Using statistics on it. We have this, so let's use it, right? We have descriptive statistics we've talked about. Looked at linear regression. It helps us, enables to make recommendations. The different types of charts we looked at. So these are some of the areas that we addressed. So again, your homework for week 3, your discussion question, and then your assignment, which is discussion questions 1 through 4, and then exercise 12. And that should be on page somewhere around 190. Let's see. Yep, 190 it's going to be on. And take your time. You're going to be looking up data. All right. Thank you.